Hi, my name is Anshui. I'm from Session 2. Today, I would like to present part 1, which is construct a appropriate graph or chart to compare the relative frequency and cumulative relative frequency in each dataset. Before we proceed to this part, we must find the relative frequencies first by dividing the dataset into certain ratio of classes and find its frequencies. For the relative frequencies, we will divide the frequencies for each class with the total number of e-commerce websites in Malaysia, which is 30. Next, we will continue to find the cumulative relative frequencies with adding the current relative frequencies and the previous relative frequencies. This process will be continued until the final class range. So this is the table of 4 website metrics: numbers of visit traffic, number of purchase order conversions. The total relative frequencies and the cumulative relative frequency for both website metrics is 1. After doing all the calculations, we can start to construct the graph. This is the relative frequency graph for the number of visit traffic, and also yet give the graph to show the cumulative relative frequency. The number of purchase order conversions, the graph that we use is same with the number of visit traffic, but the data is based on the number of purchase order data and same calculations. Overall, the result of both website metrics is very big difference. So the point of my view is the number of purchase orders is not influenced by the number of visits.
Part 2. In this question, required to calculate and compare measure of central location. Firstly, we have to identify the measure. To find the central location, there are few ways to be measured, which are the mean, median, and mode. Measure of central location using mean refers to using the formula sum of term divided by the number of term. It is often referred to as the mean or the average. The mean is sensitive to outlier. Consider to the question, mean of number of visit in million. The sum of term is 1131.4 and the number of term is 30. Hence, we can get the mean of 37.71. On the other hand, mean for the number of purchase order in million is 166.82. Next is median. Median is another measure of central location that is not affected by outliers. When the data are arranged ascending order, the mean is the middle value if the number of observation is odd, or the average of the two middle values if the number of observation is even. In the question, the number of term is 30, which is even. Therefore, we have to use the average of the two middle values after arranged in ascending order, and we could get the median for number of visits in million is 34.5, and for the number of purchase order in million is 163.9. Last but not least is the mode. The mode is another measure of central location. The most frequently occurring values in a data set used to summarize qualitative data. A data set can have no mode. One mode, which namely unimodal, or many mode, so-called multimodal. Based on the question, the mode for number of visits in million is 34.1, since the value appears most often. In addition, mode for purchase order in million, there is no mode, as does not have a value repeated.
My name is Brandon Teo Soon Hock, BB221610447. I would like to present part 3, which is calculate percentiles and construct box plot in each dataset. As you can see from the slide, there is a formula for calculating the percentiles. For the first quartile, Q1, 25th percentile is on the 7.75 observation. The number of value for number of visits is 31.95 million, while the value for number of purchase order is 140 million. For the second quartile, Q2, 50th percentile is on the 15.5 observation, the number of value for number of visits is 34.5 million, while the value for the number of purchase order is 163.9 million. For third quartile Q3, 75th percentile is on the 23.25 observation. The number of value for number of visits is 45.425 million, while the value for number of purchase order is 197.55 million. So from the table, there are minimum and maximum value for both number of visits and number of purchase order. The formula for interquartile range IQR is third quartile minus first quartile. The IQR for number of visits is 38.915 million, while the IQR for number of purchase is 57.55 million. If any value is less than Q1 minus 1.5 multiplied by IQR, it will be called out as a outlier. If any value is greater than Q3 plus 1.5 multiply IQR, it will also be called as outlier. So this is the box plot for the numbers of visits where the outlier is 54.2 million and 23 million. Third quartile is 45.425 million, while the median is 34.5 million and the first quartile is 31.95 million. So this is the graph table for number of purchase where the outlier is 231.9 million and 116.5 million, while the third quartile is 194.175 million and median is 163.9 million and the first quartile is 141.075 million.
Hello everyone, my name is Lao Li Chan and my matrix number is BB2211008. So next, I'm going to present part 4, which is calculate and compare measures of separations between the two matrices. So here is the formula that we will use in part 4. And this is the data set of the number of visits and number of purchase orders of total 30 e-commerce websites. And the next, this is the calculation for S minus mean and S minus mean squared that we will use later. Last, so this is the overall result. First, range is equal to maximum number minus minimum number, where the matrix is 31.2 for number of visits and 114.7 for number of purchase order. Mean absolute division is modulo S minus mean divided by N, where number of visits is 37.71 and number of purchase order is 166.82. Variance is total number of S minus mean divided by N, where number of visits is 76.10 and number of purchase orders is 987.59. And standard deviation is the square of variance, where the number of visits is 8.72 and number of purchase order is 31.43. And the last one, coefficient of variance is standard deviation divided by mean, where number of visits is 0.23 and number of purchase orders is 0.19. And that's all for me. Thank you.
My name is Maxwell Linky An. My matrix number is BB221100198. I'm going to be talking about measures of association. In order to calculate this, we need sample covariance. The formula is provided in the slide. Variable X is the number of visits, while variable Y is the number of purchase orders. Referring back to part 2, the mean for number of visits is 37.71, while the mean for number of purchase orders is 166.82. The table provides the values for variable X minus its mean and for variable Y minus its mean. Once the mean is subtracted, the data from both of these columns will be multiplied together and summed so that we can calculate the sample covariance. Once the data has been multiplied together and summed up, we will get a total of 5130.36. Next, we need to find the number of items in the data set, which is 30. So according to the formula, we need to divide this total value by n minus 1, which is 29. Therefore, we will divide 5130.36 by 29, which gives us a value of 176.91. From this, we can infer from the positive covariance that the two variables move in the same direction. This indicates that the higher the number of visits, the higher the number of purchase orders. Next, we need to calculate sample correlation, and the formula is provided in the slide, where it is covariance of variable x and y divided by the product of standard deviation of variable x and the standard deviation of variable y. Referring back to part 4, the standard deviation for variable x is 8.72, while the standard deviation for variable y is 31.42. So we need to calculate 176.91 divided by 8.72 multiplied by 31.42, which is equal to 176.91 divided by 273.98. We will get 0.65. The positive correlation indicates that the two variables are directly related and they move together. The high correlation value of 0.65 indicates that there is a strong correlation between the two variables.